Gracias, muy buenas noches. Gracias por estar aquí con nosotros. Venimos de Brocade Communications. Está con nosotros John Hudson, es Global Solution Architect, viene directamente desde San José a platicarnos de OpenFlow e Internet 2.
Thank you very much. I do appreciate everyone. Seems actually fairly alert considering it's been a long day for all of you, so I do appreciate you guys staying around. So we're going to try to not spend too much time because I realize it's late in the day, but I want to give you guys a little bit of background on what's happening both from a OpenFlow standard point of view and also some of the groups that are actually working on it. And then we'll go a little bit into some of the practical uses of it and where it's actually being deployed today. From the point of view of, the last thing you want to do whenever you're trying to build a new technology is to take what, is often referred to as the build it and see if they will come approach. A bunch of engineers just sit around and go, oh, it would be cool if. And then they do it, and then you have to run around and find a market for it. But once in a while, you get lucky. For the most part, it's not a good way to do things. And so one of the things that has allowed a lot of us to get very aggressively into OpenFlow and have really put a lot of energy and time into it is the freedom that is permitted by the fact that we're solving a real problem. We're actually trying to address something that is causing a lot of people not only sleepless nights and stress, but in many cases causing them a lot of money. Because essentially what happened is a premise failed. The belief in the mid-90s and going forward was that, yeah, there was a huge capital expense to building a carrier, there was a huge capital expense to building a data center, but that if you scaled large enough, that eventually the economics would work out and you'd actually start making profit. Well, what we found is in a lot of cases we were wrong. The truth is that you hit a point where the complexity becomes so severe that you end up actually having to build a lot of very custom solutions and do a lot of very unique things that then means that you're not actually benefiting from the kind of scale that you thought you would. And so we now end up in this world today where people are talking about clouds. And, for me and for a lot of my friends, the term cloud is actually very frustrating because if anything, it's proof to all of us that marketing actually matters. In that cloud is software as a service, it's platform as a service, it's utility computing, it's you name it. It's nothing new. It's what we've all been trying to do for 15 years. No one cared until they started calling it a cloud. So fine, they call it a cloud and now we get to work on it. But when you look at what a cloud really means, it means two very different things for the end user versus the actual person providing it. From the end user's point of view, it becomes this very kind of easy to use tool that allows them to scale and grow their business. But from the point of view of the person providing it, you're looking at a lot of complexity. You're looking at things like multi-tenancy requirements, which are actually fairly difficult to do in a lot of environments today, depending on budget. You have the isolation that goes along with it, security aspects to it. SLAs become, you'll have people argue that it wasn't always the case, but I would disagree. I believe that expectation management has always been the key to successful IT organizations. I may, run the, 100-meter dash in 15 seconds and be terribly proud of myself. But if you were expecting me to do it in 9, I failed. So, being able to take things like SLAs and some very proactive monitoring and actually take a much more aggressive approach to how you deal with what is good, what makes a customer happy, it certainly can get very, very interesting. Shared services from the point of view of really sharing them. You look at a lot of technologies today, a lot of deployments will use things like VRFs, right? And what ends up happening is, depending on how they build it in their environment, they still end up replicating a large amount of hardware, which kind of wasn't the point, right? I mean, the whole point was to be able to share some of that cost. You look at service insertion, and this is something that's very dear to my heart, in that, what no one likes to talk about is that a large number of errors in a given year in data centers are caused not by technology. They're caused by humans. They're caused by people making typos and mistakes and pulling the wrong cable and shutting down the wrong system. And it's not because they're not well trained, it's because half of them haven't slept in 2 days. It's because we force people to do maintenances at 2 o'clock in the morning on holidays, and there's too much oxygen and too much light, not enough clocks, and they make mistakes. And so once you start getting into a model where you can start building a shared service model, this becomes even more critical because now you have a larger number of individuals that can be impacted by an outage. But what it also provides is an opportunity to start looking at things like service insertion from the point of view of how do we get to a point where adding capacity is not a change control. It's not a 6-week planning event where I need 3 levels of approval and I have to do 5 dry runs. It's something I can do on an idle Tuesday while drinking coffee, right? It's something that I can do very easily. It's something that becomes a very kind of safe sort of normal routine for me where there isn't quite so much risk around it. But the truth of the matter is that all of this is very, very difficult to do today. Modern networks are very rigid. And it's not just a network, it's the data center. It's the way most facilities do business. You know, this idea that you have a data center and there's a room and there's a rack and there's a row and there's a slot and there's a server and there's a MAC address and there's a license key, and this is all very fixed assets that kind of come down to a single entity that you can actually walk up and touch. And that's not really what provides a sort of nimble environment that most people are requiring today to actually not only meet the needs of whatever business model they're seeking, but to also get around a very serious problem that has occurred, and that is the idea of circumventing the engineering group or circumventing the IT department. Because essentially it takes so long for a group to actually provide a service that the customers stop asking. And they just go to someone else and they get an outside service to come in and do it. But it also means that you're not able to take advantage of a lot of the new technology. You're not able to actually start looking at your IT organization not as a sunk cost, not as something that is a necessary evil that you have to do just because you need email, but actually look at it as something that becomes a competitive advantage in your environment. Catastrophe doesn't always have to be a bad thing. You take, for example, Walmart. So Walmart has a weather center that actually monitors weather patterns and tries to predict, based on that, what sort of goods should be shipped to certain stores, right? So logically, you know, if a tornado is coming, you might ship, you know, plywood and nails and so forth. What they found is that when people think the world's going to end, you know, like hurricanes, they like to eat strawberry Pop-Tarts. I haven't quite figured out exactly why strawberry Pop-Tarts. I've been told that it's because they are the only Pop-Tart that tastes good cold. But the result is that they pre-ship large amounts of Pop-Tarts to the Walmart facilities that are actually in the path of hurricanes. Now, they don't charge more for them, right? That would be taking advantage. But by knowing that there's that need, by knowing that this is an environment where that need is now created, and by meeting that need, they've now not only taken something that is normally a rather unfortunate event, but actually seen it as a way of actually providing additional benefit, additional services to their customers, because they're able to be that nimble because of the way they deliver services. And so when you start looking at this, you have to start asking questions. Why can't I, build it optimized for the kind of demands that I need? You take, most data centers build based on a common load level, right? Whatever nominal is for that given period of time. And then on a really big day, like a holiday or something, everyone goes in and they sit and they wait for something to break. This isn't really a great model. You end up with a lot of situations where during the very period of time where you need your services to be available, or the very time those services aren't available because of the amount of load that's being induced. You look at how you're going to start dealing with the asset utilization, how you're going to start dealing with the, how do you really become nimble? How do you really get to a point where, today a lot of the friction that exists is because business moves at this speed and IT moves at this speed, and it creates friction. And how do we get to the point where we can, either at a service provider level or at an educator level or at a business level, start actually speeding up the way we deliver these services to the point where we can deliver them at the rate that business requires it and alter them at the rate business requires it so that you don't create that friction. Being able to really start looking at how do we start customizing the offerings that we give. How can we start looking at a certain customer and say, oh, you're in the healthcare business, and we know that the healthcare business has these sort of characteristics, and we would like to be able to offer some different subset of features that we know are beneficial to your business line. And then, of course, how do we start really unlocking this? And this becomes very interesting, and I'll touch on this a little more at the end, but what I'm about to go into on what OpenFlow is today is really about a set of tools. We were creating hammers and screwdrivers and wrenches. Without the hand on the tool to actually feel the amount of pressure that's being pressed against the palm as you turn the wrench really doesn't have a whole lot of value. And so we're going to talk a little bit later about how you start looking at analytics and how the feedback loop for OpenFlow becomes, in many cases, more critical than the actual tool itself. So what were the goals, or what are the goals of SDN? Well, it depends on who you talk to. There are some pretty aggressive ideas. A lot of people will draw analogies back to mainframes. The idea that what the x86 market is, this idea that I don't have to buy an application from the same person that makes the OS, from the same person that makes the computer, to the same person that makes the networks, to the same person that makes the storage. I don't have to buy this monolithic piece. I can go down to a store and I can buy a motherboard and I can buy a hard drive, the operating system I want or the hypervisor I want, and I can install VMs on it, and I can basically build it how I wish to build it. And this is essentially what we're now doing to the networking industry. We're basically saying, okay, we don't really want to. I hear it all the time from customers, my customers and other people's customers. I use 1/10 of the features that box has. Why am I paying for all those features? I think, well, usually the features are bundled, so they can do a little bit of picking and choosing, but for the most part, you get what you pay. So how do we take the resiliency that currently exists in a lot of networks and provide it in a model where essentially you can do a homebrew router, right? Where you can basically take an OpenFlow controller, which we'll get into a little detail what that is in a second. Take an OpenFlow controller, put it on some commodity hardware, throw some quote-unquote applications on it that may be a routing protocol or a pair of analytics. And essentially, how do we create this model where you can build this to your liking? You can build this how you need it. You can build it in the way you want it, and you can build it at the price that you need it. And while certainly, I have a lot of friends that are mainframe guys, and they'll point out the fact that many of the new features that I get excited about are just things that they've been doing for years. And so, yeah, maybe we're not innovating quite as fast as we could, but we're providing it to a much larger customer base, which means that a lot more people are getting to benefit from it, and a lot more people are getting to use it. And that ends up creating innovations in ways that you might not have expected. But in many ways, even if you don't think of it as being the next x86 revolution, it is definitely a shift in that, from the point of view of, so not a lot of organizations do a lot of tool development, right? Write their own tools for managing their networks or their environments. Now, I deal with a lot of customers that are fairly unique. Certainly from the Silicon Valley, Facebooks of the world and Googles of the world, but also government entities and different three-letter acronyms and agencies. And they have pretty unique needs, pretty unique sets of characteristics that are not like anyone else. But they can't write a really complex tool to manage it, because if they do, they'll essentially build themselves into a vendor lock-in, right? The tools they write will tie them to that vendor. And when that salesperson finds out that they're tied to that product, you can probably guess that discounts may not be quite as aggressive. So they don't. So one of the things that I'm so excited about when it comes to OpenFlow is the idea that I can now create an abstracted management layer that allows a Google or a Facebook or a whoever to actually safely justify putting some time and money into writing a tool that's specific to them, and know that they can do so safely, because since they're writing to this abstracted layer and not to the hardware itself, if that vendor decides to not support a feature they want, or to stray away from standards, or to not offer aggressive enough pricing, they can swap that vendor out without having to rip out their tool. This is a kickback against this concept that exists in a lot of the industries today of that it's a good idea for me to trap my customer. That it's a business strategy to essentially make it so difficult for my customer to leave me, so difficult for my customer to remove my hardware from their environment, that they would rather just put up with me than actually swap me out. And personally, I would much rather companies continue to buy product from me because they like it, because the support's fantastic, because the pricing's really good, because they like the features I'm offering, because it makes their jobs easier or it makes their business more efficient. Not because I've tricked them into some kind of scheme where they can't leave unless they, without spending a boatload of money. Now, when you start looking into what does this start to look like when you start building it, and essentially you can draw analogies to hypervisors today or many other technologies. But it does require that you have an understanding of what the difference is between a control plane and a data plane. In that, most devices today have some sort of separation of control and data. And the challenge has always been that the requirements of control and data may actually not scale in the same way. So how do you accommodate for this? Well, you come up with different products, some that have deep buffers, some that have deeper memory environments, some of them have faster, process boards for certain types of features. But wouldn't it be nice if you could decouple that? So essentially you have a set of devices that do data plane operations, so actually moving of frames. And then you have a separate setup of the actual devices that run the intelligence, the routing or the labeling or whatever other sort of operation that you're doing, that would then allow you to scale that separately, right? So let's say you decide that you don't need any more ports, or you don't need the upgrade to 400 gig tomorrow. But you do find that your route topology has grown to a point, or the number of devices you have to support has grown to a point that you would normally need more devices. Wouldn't it be nice if instead of having to go buy a new device, you could just buy more control plane, right? If maybe your control plane was running on 3 x86 boxes before, now it can run on 6, right? And so being able to scale those independently. And so this provides a very interesting growth opportunity for different network environments through this process of creating a standardized programmable interface. And you hear some people talk about this idea that what is SDN, and is SDN OpenFlow? What about VXLAN and STT and NVGRE, and how many acronyms you want to throw into your soup? And you can also use that control plane data plane analogy to kind of separate those. In that essentially, what OpenFlow is really a programmatic approach, a control plane more focused approach to essentially solving this problem of scale. The VXLAN, NVGRE, STT, now Dove, the standards version, or hopefully eventually version, NVO3, they're more on the encapsulation aspect of it. So you can think of that as being more data plane, sorry. So we're just focused more on the OpenFlow side of it today. But what it does is that by standardizing that interface, by standardizing the way that you interoperate, you not only provide what I mentioned before, of being able to actually develop some tools that, maybe are really useful because you raised llamas, right? And not a lot of other people raise llamas, so you want to be able to design your network to benefit llamas. But it also means that you can start taking away some of that chokehold that exists in certain customer bases, right? Take away some of that extreme influence that certain groups have over other customers, because essentially they've gotten so deep into the rabbit hole that it becomes very, very difficult for them to back out. Now, who's behind SDN? Well, so I work in the IETF for Brocade, among other things. And one thing I found very funny as ONF started kind of getting started was that, you hear from the IETF guys that the, IEEE doesn't, move fast enough. And then, IETF, gets kind of long in the tooth, and they've been around for a while. And now I hear from some ONF guys that they like it because it's faster than the other standards bodies and they get more done. It's like, well, wait 10 years, see how that goes for you. But there is a difference in that ONF was bootstrapped by companies. It was bootstrapped by customers as opposed to vendors. Now, needless to say, all the vendors have since gotten involved because, heaven forbid, these customers do something on their own. But essentially, Deutsche Telekom and Microsoft and Facebook and Verizon and Google and Yahoo and we're the founders, and there have been a lot of other additions since then. But I would argue actually that Google's been probably showing the most interesting use of this as they've kind of gone on. In the IETF, there's been some developments that have been working on for a long time, things like forces and so forth. Certainly from the provisioning point of view, we have things like OpenFlow and NetConf. Not just OpenFlow, but SFlow and NetFlow and NetConf. And right now there's a lot more research going on than necessarily, actually kind of deciding a path forward. But it has been a very, very cool thing seeing the passion and the amount of energy that people have been putting into this. At the IETF meeting in Paris, we had the IRTF, a research group, come and present on SDN. And you go to a lot of sessions in the IETF, and it's kind of like this, right? You get a lot of chairs, and there's good amount of people there, but certainly not packed, right? This room was filled to the brim. There were people sitting on the floor, there was people lining the back wall, and there was 6 rows deep of people standing outside the door trying to look in. And not that I've been doing IETF work for a long time, but I'd certainly never seen that kind of reaction to anything before. So the amount of energy and interest and the amount of brain power that's being thrown at this is actually really, really impressive. And on a personal note, just very, very exciting. It's nice to see so many people getting together and trying to actually figure out how to do this right. Now, these slides will be available for you afterwards. I'm not going to dive into all this text. I think it's way too much text for a slide, but I want to kind of give a little bit of background on where this has been coming from. So, it all did start essentially, back in about 2008. Like I said, there has been some other work going on, like forces, that's been going on for 10 years. But essentially, there has been a lot of real movement in the last probably 18 months. The Forward Obstructions Working Group plowed forward basically as a result of some of the challenges that were occurring after, in October 2011, Google showed this idea of what they thought a 2.0 version would look like. And there was enough differences and there was enough challenges in how we'd actually get from one to the other that essentially this kind of kicked off this idea of a Forward Obstructions Working Group. So essentially the key drivers for the Forward Obstruction Working Group is how do we get from 1.1, how do we basically migrate people, and how do we basically see that this doesn't actually impact the adoption rate, aside from some other things. And so there's been some phase 1 goals set, but essentially it's been, really kind of focusing on, certain key parameters, like, how do we do table type patterns, how do we, start going toward a member-driven convergence approach, and certainly how do we maintain supportability without sacrificing feature sets. Now, to kind of show how this has gotten a little messy, I've just kind of walked through this real quick on the different versions that currently exist. So there's 1.0, which is the most widely kind of deployed, but you could argue 1.0 is actually not terribly useful and it's fairly minimalistic in what it's tried to do. You have 1.1 and you have 1.2, and then you have 1.3 and 1.4, and then you have 2.0 that is being defined. So already in a very short period of time, you've seen a lot of change and a lot of movement, and the truth of the matter is that when you're designing protocols, when you're designing things like this, it's very, very difficult to find that happy medium of how do we ensure progression, and how do we ensure that we're gaining, and how do we ensure that we're seeing enough innovation without creating these drop-off points where customers are abandoned, and without sacrificing design quality for achieving that goal of interoperability. So, as I mentioned before, with OpenFlow, what you have is a decoupled controller or a decoupled control plane from the device. So this allows you to then create these separately scalable environments. Now, what this means in practical deployment is that you're looking at things like flow tables. So you're basically saying, okay, I'm going to create, this set of priorities, and I'm going to look at packets and basically match on certain characteristics. And then based on the certain characteristics, I can actually take action. And so if you look at the flow table entry for OpenFlow 1.0, we essentially had this fairly, basic pattern of matching fields, actions, and stats. And actions would be, forward, add, remove, drop, or send a packet to a container. Moving to 1.1 and then 1.2 and 1.3, we start adding this idea of multiple tables and how do we essentially have things like a go-to and start looking a little more database-like in essentially how you deal with the data content. So I encourage you to, definitely there is a phenomenal amount of information on this online. Stanford's got a bunch of great videos that you can watch, good talks on to go into a lot more depth than I've been able to here. Certainly the ONF and others have been broadcasting, what they've been doing and what they've been seeing. I don't know, if any of you get involved in NANOG at all. But last couple of NANOGs, there's been some good presentations on how different people are actually looking at this. If you have a chance to see one of Google's presentations on what they're doing, it's very, very interesting because it actually gives a very real business reason for doing it. And that what they show is that instead of basically beginning the upgrade process of links at about 50% load, which is what most people have to do, that they're able to, because of the amount of the granular level of control they have, they're actually able to run links at 96% load and keep them at 96% load and actually be able to shift flows around to maintain that over a period of time. And so I don't want to go too much into it. It's their project, but I really encourage you to take a look at it. So, almost out of time here, but what's going on in reality, right? So if you're not a Google and you don't have all those research developers to do that work for you, what else is happening, right? Well, so I don't know how many of you are familiar with Internet 2, but essentially, everyone gets very excited when any movie has a sequel. And the approach, has been based on a lot of different technologies for a long time, but it has basically become a fantastic focal point for a lot of this OpenFlow research. So certainly, currently 49 customer locations, about 15,000 miles of dark fiber, and about 8.8 terabits of capacity. And so essentially, through work with the Internet 2 and some others, we've been able to take, certain universities and basically really bring them into the fold of being able to really start taking advantage of some of the research capabilities and, how they actually start, kicking the tires and actually getting a sense for, what sort of value might OpenFlow actually bring to their environment. And as you can see, the Internet 2 network has a lot of participating members and a lot of different facilities and partner research groups. And so the kind of knowledge transfer that's occurring as a result of the work they're doing has been quite fantastic. And then beyond that, companies like Brocade that have kind of stepped out and really kind of pushed, how far they can get OpenFlow going, have been actually seeing a lot of traction. And we, for example, have a lot of trials going on in many different locations. This slide's a bit old now, but there's a lot of very interesting work going on. So, a little bit about what's next. I got about 2 minutes here. So why would you want to have this wrench if you don't know exactly how hard to turn it? So there's a whole nother side of the world, and when you start looking at how you do business analytics and how you start doing lawful inspection and how you start doing really fine-grained sort of analysis of traffic patterns. And so essentially what a lot of us believe is that this is where this is going to evolve to, where essentially you're going to get to a point where you have some very, very elegant marriage of a flow analytics type technology with a open flow type tool. And that if you are not only using OpenFlow to take these actions of drop or add or whatever, but are then actually pulling information from the network, not just interface statistics, but actually content-aware things like what sort of events might be happening in the world, or what sort of weather events might be occurring, or political events, and actually be able to use that to feed that information back into the system so that essentially something like OpenFlow can be making much more intelligent decisions. And so it's really this, there's a lot of work that has to be done in how do you build the wrench, how do you build the screwdriver, but the kind of end vision of, why would you want to see this? And a lot of it comes down to, I don't know about any of you, but for me, when I learned how routing worked, I was kind of disappointed. I had this grand vision of how routing worked, and it wasn't quite as exciting as I thought. And for a lot of us, this starts really kind of getting to the level of complexity and intelligence that a lot of us kind of assumed that some of the stuff was before we kind of learned to look behind the curtain and see the wizard. And so, being able to really kind of couple this very fine-grained control, being able to, at an application flow, to an actual, port pair, be able to actually control those flows and then basically take something like business analytics data and actually use that to actually make better decisions on how those flows are managed, start providing for a very, very interesting sort of model of how you start creating some extremely dynamic networks. And that's the dog and pony show. So thank you very much for your time. I really, really appreciate it. I'll be hanging out afterwards, and I'm more than happy to go deeper into anything and answer any questions you have. But hopefully for those that have been a little curious, give you a little better view, and for those that hadn't heard of it, this will encourage you to dive into it yourselves and start participating, because this is our chance to kind of do some pretty impressive stuff. And so the more brain power we get into it, the better it'll turn out. Thank you much.
No sé si tengan alguna pregunta aquí para Job. Bueno, pues, entonces no nos queda más que agradecer a Brocade y a Job por haber venido.
Thank you very much for your time.
Thank you. Bueno, el siguiente presentador, bueno, espero que pronto podamos. Bueno, para Brocade, bueno, esperemos que pronto pudiéramos hacer alguna prueba. Sí. Por ahí lo andamos negociando. Sí, ok, bueno, el siguiente presentador es si quieres,
Perdón, pero por la premura aquí que veía el tiempo ya ni nos presentamos. Bueno, yo soy Ulises Mata Betancourt, soy el gerente comercial de la región Norte y Occidente. Si necesitan algún apoyo, ayuda, con gusto. También está aquí Omar Ochoa, es el ingeniero, el arquitecto de soluciones en la parte de Brocade. Ya tenemos algunas cosas pues actualmente trabajando con la UB, también de tiempo atrás con la UDG también. Tenemos ahí algunos equipos en algunos otros lados. Entonces, bueno, ya somos un equipo, o más bien una marca ya conocida y que trabaja perfectamente. Entonces, cualquier cosa estamos a sus órdenes. Y gracias por su atención. Espero que esto de ESDN suene un poco a magia negra, pero no, al contrario, es para ver cómo hacemos eso. Muchas gracias.